Sort array by parity. So this problem has been categorized as an Amazon interview question, but I think this will be more like a question to filter out candidates rather than actually being asked during the interview. So you're given an array of integers, and you need to move all the even integers to the beginning of the array and all the odd at the end of the array. So any array that satisfies that condition is okay. So it doesn't matter whether they're in sorted, unsorted order. So as an example here, they are given the input values 3, 1, 2, 4. So they want to move 2, 4 to the beginning of the array and 3, 1 to the somewhere to the end of the array. So any order, so even 4, 2, 3, 1 is correct, 2, 4, 1, 3, 4, 2, 1, 3. So as long as the even numbers are before the odd numbers, the solution is correct. So for this problem, the way we are going to solve it is we are going to have two pointers, one pointer at the start of the array and one pointer at the end. And we are going to keep traversing down the arrays, and whenever we encounter an odd number at the beginning of the array and even number at the end, we just switch places. So until we have reached or traversed all of the elements in the array. So yeah, let's get started. So we'll create two pointers, I is equal to 0 and j is equal to nums dot length minus 1. So first thing we need to check is there if the number is even and it's the beginning of the array, we don't need to do anything. We just need to keep incrementing the count. So nums I. So we only increment the count. Similarly, if there's a odd number at the end of the array, we only decrement the count. Else, we are going to do the switch operation I mentioned. So we'll keep just switching the places of the odd and the even numbers. So and then we just increment the count again. So let's try running the solution. And submit. So yeah, the solution, so the time complexity is going to be O of n, because we're just traversing where n is the number of elements inside the array, and because we're just traversing it once. And the space complexity, so this entire operation is being done in place. So it's going to be a constant O of 1. So yeah, leave comments and let me know if there's an easier solution to do this.